Hello, the purpose of this video is to introduce the notion of adjusted statistical models. Let's take a simple example. We want to estimate the association between the height and the weight of a sample of people, represented here by the scatter plot. To estimate the effect of height on weight, we draw a line passing through the points. The equation of this line is composed of the weight as a function of height plus a constant, denoted A, plus noise, that is variability error, denoted epsilon. The slope of the line, denoted by the coefficient beta height, is the effect of height on weight. The constant here is the y-intercept, which could be, extrapolating, the weight of a person with a height equal to 0, which is not possible, and this reminds us that we cannot extrapolate the result beyond the conditions of the study. We considered all participants here, without taking into account the sex of the survey participants. Is the relationship between height and weight affected by the sex? Let's represent by red dots the woman and by blue dots the man. Men are on average taller than women, so there is a relationship between sex and height. If we pass a straight line through the red points and a straight line through the blue points, in our example, we can see that these two lines are parallel and that the slope of these lines is slightly different from the slope of the line that passed through all the points combined. Here, the effect of sex, being a man versus being a woman, is quantified by the difference between the constants of the two colored lines. This could be interpreted as men have a higher weight than women, regardless of their height. Remember that this is a fictitious example. Here, the new beta prime height coefficient, which is the common slope of the two colored lines, is the effect of height on sex-adjusted weight. In practice, we rarely have a single factor. Consider this article on fertility in women after ovarian stimulation. The authors seek to assess whether there is a difference in live birth rates between fresh and frozen embryo transfer in this retrospective study in real-world settings in China. The conditions are not controlled. The differences in age, but also in the duration of infertility or the number of oocytes could be confounding factors that would distort the estimate of interest. In this case, it is possible to use multivariable regression to take into account all the potential confounding factors identified. Adjustment is a statistical technique which allows one or more variables to be taken into account. Thus, the effect of each variable is estimated independently of the others. The effect of one takes into account the effect of the other factors. This is called an adjusted measure of association. The link between the confounding factor and the exposure has been broken. Note that this statistical method is used in the analysis of the results after the data have been collected. There are other methods to consider the confounding factors, such as matching, stratification, or weighting, and we recommend you to watch our other videos. Thank you for your attention.